Hello, hello everyone. I'm Ted, and very glad to be here in KL and to share this topic. I'm Ted, and I joined actually in Alipay for more than 8 years. And as a former member of the database SRE team, I have been actually seeing and experienced what kind of the database challenges and the infrastructure challenges that occurred in the Alipay before. And actually, after move my role to the solution architect team head in the OceanBase, I've been closely working with the different clients from the different industry, especially for the banking and the fintech industry. So that is in that the topic we're sharing today about the distributed data foundations in AI-driven financial and for the resiliency. Actually, I think on one hand, AI actually is reshaping our finance and industry, actually from the how application has been built, designed, and implemented. But on the other hand, actually a lot of the banks and the fintech companies actually now is doing the global expansion. So some of them actually are moving from the data centers to the cloud. And some of them migrate and maybe moving from the single region to multi-region design. And a lot of them actually moving from a single cloud to a multi-cloud architecture. So actually that brings a lot of the challenges from the both application side and the database side. So this is something that we're going to share. So since it's a database topic, so it's closer to the infrastructure. So in the following maybe 20 to 30 minutes, I will try not to bring you to sleep. So first, actually, I want to start with a question. So I'm not sure that how many are there in today's audience, how many are there actually a tech leaders for the banks. So this question is that how many data platform are your team managing today to running your application system? I think you can see this diagram in here. I think it looks like quite familiar for many of the platform. It's actually our application design from the top to the bottom layer actually is becoming more and more complicated today. Because that we are doing faster innovations and we are trying to adding more features, adding new systems to the platform, right? So in the underlying infrastructure, we are actually creating more data platforms, adding more ETL process, CDC data pipelines. And the problem is that this does not only actually create extra cost for the resource, actually is creating more single point failures to your system. So this actually are slowing down our innovation for the new features. So is there any way that actually we can address those kind of the challenges and try to maybe simplify some of the layer of the data pipelines and maybe about, for example, like in the relational database, cache systems, about some of the analytics platform, right? And some of them maybe for the lake house. So this is something that what we're trying to discuss. This is where OceanBase, this topic we comes in, is that OceanBase is a database that born from the mission critical OLTP system, like previously Jack mentioned, it's born in Alipay. And now it's actually today, has already actually evolved into a unified database platform, meaning that in one database core engine, in OceanBase, we are trying to address the core transactions, real-time analytics, and multimodal AI. Those three major kind of the scenarios into the system. This is the answer we're trying to provide to the industry, that to simplify our infrastructure and the data platforms and to accelerate our innovations. So before we introduce more about how OceanBase achieve those kind of the capabilities, I will spend a little time to introduce about OceanBase. OceanBase is actually a database created by Alipay. So I heard many of the users ask the questions is that why you create a new database? Why not keep using Oracle database? Why not keep using maybe MySQL, Postgres, or SQL Server? The reason is that actually during the time in 2010, we know it's a big, actually, a fast development from the internet work, right? So for the internet mobile network, all the e-commerce system, all the mobile app, actually there is a surge in those kind of the scenarios. For most of the application system, they all need to deal with the huge traffic workload, especially in China for the population here. So every point, every module of the system actually become the more and more actually hard to expand. So database especially actually is a special part, is that especially for the fintech kind of the layer, because Alipay need to deal with the financial scenario, payments, transactions, and cannot tolerate any kind of data loss, right? So that means during the time we are facing some critical kind of the challenges that even Oracle cannot help us to address, because that you need to deal with the multi-data center resilience. You need to deal with the how to fast scale out and scale in before and after your major maybe promotion activities, and how to actually support your fast iterations for your applications. We know that for Alipay itself, actually growing from a single payment tool to now it's actually a super app kind of the applications. So those kind of fast development, you need a database that can able to provide those kind of faster iterations. So that is the background. Maybe I spent a little long time in here. That is the background that why OceanBase born in Alipay. So it's actually after 2016, we already actually completed all the critical kind of the services, migrate from Oracle database to the OceanBase. And after that, we start to provide services to external clients in China. So we start from the banks and then reaching to we call the digital native services. So you can see some of the maybe familiar logos in here. And especially what I want to talk about more is about especially for the fintech services. So for the fintech sectors, from the first bank, we cooperate and provide our data platforms and the database to the banks. Basically now, OceanBase is a #1 choice in China for the distributed kind of database in China. So covered most of the top kind of our leaders from the banks, securities, insurance companies. And for the globalizations, things that we move, part of the globalized strategies with the Alipay international. So OceanBase is actually by default the A+ world first, Anton and better the data platforms. So and we also actually developed our own actually for the strategic partners and the strategic kind of customers, like in the banks showing this in this diagram. So coming back to the product-wise, so for OceanBase, it is we know that especially for banks, the database actually holding the heart of the data. Though that means this cannot be actually a lock-in kind of the technology. So that's why OceanBase is completely open source, and with the most, I think, is the open protocol, Apache v2. And meanwhile, we move our product and the services to support both as in the on-premise deployed and for the cloud managed service. So now you can consider OceanBase as a cloud agnostic kind of the service, managed service in multiple cloud providers, meaning that in any of the cloud provider here, you can use OceanBase just as the same user experience, to eliminate your kind of the learning cost and for the maintenance cost. And later on, we will share how OceanBase helped the Touch and Go to establish a multi-cloud disaster recovery kind of architecture. And from the last year, we established our our global support center in Malaysia, in KL. So that means that for moving forward, we actually have the capability to support the different customers from different time zones globally. And we have been building different kind of local team, including technical, professional service, and for the global support. So coming back to the development of in China, some of the trend in China happening in the last 10 years, you can see here for OceanBase migration kind of or maybe the implement kind of the use cases. A lot of them actually not only for migrating from a monolithic, or we say that legacy kind of architecture. Many of them found that if we only modernize the application side, but leave the database still as a single node or maybe a monolithic kind of the node, this actually eventually will not work, because that we build the new applications, we want to innovate faster, we want to provide customer different dimensions for the new workload, right? But your database is still actually as a single server. That will not work. So that's why actually so many banks and the fintech kind of the companies choose OceanBase to, during the process, to modernize your applications, just to change the database from the legacy conventional database to the distributed one. So OceanBase has been actually long time to closely cooperate with Sunlight. I think back in the 5 to 6 years ago, we have been closely work with Sunlight in multiple China major banks. So you can see in this here, we just list some of them for the successful deployment case, from the national large banks, top banks, to some of the urban commercial banks. Basically, OceanBase can design and implement different kind of the topologies of the disaster recovery and the infrastructure-wise. For example, some of the city we designed with maybe 3 data center kind of the architecture as a native distributed one. Some of them may have only 2 data centers. Later on, we will share more about how OceanBase can provide customer a 0 RPO kind of the capability of the database under 2 data center. So in many of them actually has been achieved the fast resilience and will be a low cost and higher performance kind of result. So take one of the use case as example. Bank of Communications. This is one of the big key accounts we cooperate with Sunlight in China. So we migrate and actually out from the mainframe for the Bank of Communications to the modernized architecture, meaning that before that, actually these Bank of Communications, their credit card system actually are running on the legacy kind of the mode. And we know that all kinds of the disadvantages for the mainframe. It's stable, it's a high end, but actually you can very hard to do some of the, actually you cannot improve it. The only thing that you can do is scale in the MIPS, or maybe you need to offload some of the workload from the mainframe to the other new systems, but this is actually eventually not the total solution. So that's why Bank of Communications eventually choose to totally rewrite their system into a modernized system. So in OceanBase, we designed those kind of the database architecture as in the 2 data center within the 2 cities, but with the 4 data centers with multiple replicas. Each of the data centers crashed will not impact your overall kind of the data consistency. Meaning that your database, any of the data center crashed, your database will recover within 8 seconds. And this actually improves the batch jobs significantly and reduce the cost. Another case here we show is that one of our ongoing case that we're cooperating with Sunlight, one of the Southeast Asian of the banks now. So this is the architecture we mentioned about how do we provide resilience and the distributed kind of the benefits to the banks that only has 2 DC. So you can see in here, the way we designed the topology is that when DC1, DC2 is actually the data center that the bank already have. And we deploy 4 replica in these 2 DCs, meaning that 4 data copies. So our core banking workload actually can running parallelly in multiple nodes. That means in any of the time, if your workload actually is apparently high, you want to scale, the only thing that you need to do is adding more nodes into the cluster with no actually manual separate or maybe sharding, without actually application to using any middleware. So you can just scale the OceanBase cluster. OceanBase will rebalancing the different splits of the data, and this is totally transparent to your applications. Then what does it do in the DC3? This is a technology that we want to introduce today. Is that we know for most of the distributed database that usually requires 3 full data replica. That basically, except the OceanBase, all of the new SQL database will require that because we designed based on the consensus protocol, right? But OceanBase actually, we introduce a new technology we called arbitrator node, meaning that this node will know keeping data, not storing any data, not storing any transaction log. Only one thing is joining the voting process in the Paxos protocol. Paxos protocol means that decide who is the leader now, who should be the primary instance to avoid brain split issues in the typical 2DC kind of design. So in here, OceanBase arbitrator node, since it's with no data, with very low kind of the requirement on the hardware, you can manage 4 CPU, 8 GBs of RAM to manage hundreds of the instances for database. That means you can put it on cloud. This is something that we are already working on with the bank now. The bank actually has separate cloud VPC to connect with the 2 data centers, their on-premise data centers. And with this kind of topology design, in OceanBase, it can tolerate any time for the node crash failure, even with the data center crash failure, with no data loss. This is with no human intervention. Basically, all happened automatically and fail over automatically. So this means a lot when banks want to achieve kind of the resiliency, active. So because that you can see here in DC1, DC2, all the servers actually, there are no kind of the primary or standby kind of the concept. All the nodes can be leaders for part of your partitions, meaning that you can deploy both of the applications in both DC. It's achieving the active process. Okay, let's move to the next. So talking about the design topology, OceanBase actually spent a quite long time to trying to design a kind of the architecture can support from a single node, single DC, to multiple node, multiple DC, which means that OceanBase has a standalone version. You can, for some of the tier 3 kind of system or maybe non-production environment, you can start from node 1. And you can add on to scale to node 2, node 3, maybe 10 nodes. Largest kind of a cluster can be up to thousands of nodes. So this is actually the benefit of the distributed kind of design for the benefit. So as limited of time, we will not deep dive into each of the kind of the architecture in here. So basically, we found that different mode actually can suit different kind of the infrastructure kind of the condition from different banks. So sharing one of our use case here is actually one of our global systematically important bank. So if anyone interested, we can discuss is in offline for more details. Basically, this is architecture we designed from Shanghai to Guangzhou, actually with the three data centers. In Shanghai, we have 2 data centers, but we put the arbitrator in the Guangzhou, which means that this is a totally distributed design, and the transaction commit will be within one city. Means that your latency will be still good. Only when one of the DC or maybe even with the city level has some of the power failure, earthquake, you can fail over to the Guangzhou region. So this kind of the mechanism between Shanghai and Guangzhou basically actually is a technology, is a primary standby kind of technology. You can consider that OceanBase can work as in both native distributed kind of design, but also you can attach a conventional primary kind of the cluster as in a more extreme kind of the disaster recovery kind of the design. So this is actually a typical kind of solution for most of the banks that has the top level resiliency kind of the implementation. Okay, next we talk about cloud. Remember we mentioned that OceanBase can support both in the cloud and on-premises, right? So in cloud, OceanBase now, we are available in the marketplace in AWS, in Google Cloud, in Microsoft Azure, right? So the interesting part in here is that OceanBase can achieve is that, for example, your core banking system, we know that for some of the region, core banking can be on cloud. So for those kind of the clients, they can build their applications, for example, your primary as in the AWS, your standby is actually in the Azure, meaning that anytime when there is a cloud incident, cloud outage, you can also exit very fast and to recover your business. We know that in the recent years, cloud incident actually is not that. Actually, we're seeing a lot of kind of cases like that, right? So this is the solutions that we designed for this kind of a scenario. So that's what we did from the last year. We cooperate with the TNGD, Touch and Go, and we designed multiple layers of the multi-cloud design. For example, for some of the use case for the merchant wallet, we designed as in the from Ali Cloud to the Microsoft Azure. And for one of the project is this actually more important, more mission critical. It's called eSub. The primary is on the AWS, and standby is in Azure. So that actually creates a very cloud resilience kind of architecture to the TNGD. And actually, this is the cost of the overall TCO is actually can be controlled. This is because of some of other kind of the technology we provide. For example, like the cost saving in the storage part. So we can discuss maybe if you're interested, we can discuss in off the stage. So another part is for HTAP. We mentioned is that how can we achieve that multiple workload in one data platform? Because we talk about the CDC, we talk about ETL, right? Those CDC and ETL actually need a data team to manage, not only for the cost, but also for the risk control, right? In OceanBase, we have the native column and the row store kind of storage engine built in as in one database, which means that you do not have any ETL process. Your transactional workload running on maybe the 3 replica in the row store, right? Your analytics can be running on the column store as a completely physical isolated replica, meaning that they will be not impacted for each other, but they will be improved efficiency. And this is one of the use cases we have in Indonesia to using OceanBase to achieve that the HTAP kind of scenario, comparing their existing they are using the MySQL kind of database on cloud to doing the same thing. So basically, after switch to the OceanBase, the performance actually improved hundreds of the times than before. This is because of that the OceanBase, the optimizer can support natively parallel kind of the compute for the complex SQL in the large data set. Another topic is that we talk about is about compatibilities. We know that especially for banks, migrate from legacy systems, they have 2 approach. One approach is that completely, like we cooperate with Sunlight, is that we completely rewrite and refactor our existing system, right? This is actually maybe we'll spend more kind of the time and more engineers. Another way is that, is there a way we only replace the database? For example, we don't touch the application layer, but we try to replace maybe their underlying kind of system, especially from MySQL or Oracle database. The answer is yes. OceanBase, because the mission around OceanBase in day one to create it is that to help the Alipay to migrate out from the Oracle. So we create OceanBase Oracle compatible in day one. Oracle compatible means that compatible with the data types, with the store procedures, including those most complicated PL/SQL procedures, meaning that your 90% of your store procedures can, without any code change, just copy and migrate to the OceanBase, and you can just run it. So that 10% actually are different corner case that Oracle provide, because we know that we need to admit Oracle is a very powerful and a very good product, but it's actually already developed for 40 years. So many features actually no other product I think today can 100% compatible. So that means in OceanBase, we have those kind of the mechanisms that can help the client to migrate, lift and shift approach to migrate out from the existing platforms. So since limit of time, I will speed up this part. So since Ping An Bank, we help them to migrate out from the eSIF system from Oracle database to OceanBase to achieve into a distributed architecture to linearly scale and the faster kind of the improve the information, improve the performance. Okay, finally we talk about AI. So I think that in recent years, I think just these days we keep talking about the most popular, the latest model, right? Actually, this is the most of the from the internet we're talking about every day. Like in these days, Anthropic kind of the news, we're releasing the most powerful models. And for example, there's another SOTA models released and killed any kind of the startups. So people are actually with many passion to talking about this. But we know when it comes to the enterprise, especially for banks, we are not actually talking about a model. We're talking about the data. So whether it can be landing in the bank environment, or we say whether you can find a real use case in banks, usually this depends on how you deal with the data. But the data issue is just like we mentioned, too many fragmented kind of the platform. You have Redis, you have MySQL, you have SQL Server, you have the MongoDB, you have HBase, you have Oracle, different kind of platforms actually, and you have the vector database, maybe something you deal with to build maybe your agent system or RAG system. So all these actually are separated. So what OceanBase did here is that we natively support these multimodal data types, meaning that you can achieve a hybrid search kind of the concept in OceanBase, meaning your scalar data, meaning RDBMS, table and row kind of data, including the key value, including a JSON, a GIS index, spatial index, including the native vector data type, all in OceanBase, you can deal with the SQL optimizer, meaning that for many of the use cases, you need to maybe write and connect through MCP from different platforms, right? In OceanBase, you can just in place to implement in the database. So that will be actually improve the efficiency a lot. So to mention one more part about OceanBase in here is that we talk about we call it AI functions. AI functions means that in OceanBase database kernel, you can actually make your data stay closer to the LLM, meaning built-in database AI functions can directly transfer your data, your unstructured data, to call the LLM API to do embedding, to do parsing, to do analytics, and form into a structured kind of the analytics To show one of the use cases here is that, for example, we have a customer complaint kind of the recording for the kind of the service team, meaning that a customer is very angry about failing transfer and complaining about cancel the cards and if anything, if their requirement is not fulfilled. So those kind of the audio basically in previously need to be reviewed by human or some of the dedicated platform. You need to analyze this original maybe a MP3 kind of file, right, recording file, and then see that what kind of the background is this, what is the risk here, right? This is something that we usually do before. In OceanBase, what you can do here is that you put this original recording column as in the database, and OceanBase internally calls the LLM to analyze this recording file to see what is the situation here, what is the major risk, what may be the next action that the client may do. So, and after AI functions analyze those kind of the behavior, will be fulfilled back to the table. Remember, this is still a relational database. Fulfilled back to the table, and your unstructured data will be a structured kind of an analytics kind of the data. So this is something that we have been done as in a multi-model engine. So we need to note that for all the features, all the capabilities we mentioned in today for OceanBase, it's not for a different kind of model or different product to combine. It's in one product, one database kernel, meaning that in this all-in-one database kernel, you can achieve such kind of the multiple workload. And on top of this kind of the database kernel, we developed our own product as in for the analytics, meaning it's called Data Pilot. Data Pilot means that actually is provided to the bank users and the fintech users is for that. You don't need to have technical background, and you can just work as in the analyst kind of the role. You can just speak natural language to your data, your business data, with the controlled privileges, right? And to get the insight. So those for the kind of the semantics, kind of scan, or kind of analytics, what kind of the relationship between your different tables. We have a separate mode. We call the data scientist mode, meaning that your data scientist can predefine some of the data relation within the data pilot. And after that, your different department of the analyst can just speak natural language to get the insight. This will be shorten the insight from weeks to minutes, and we already have some landing cases for the bank users, and we also actually are cooperating with Unto International for some of their internal models to do some further kind of analytics for this part. In the last part is that about roadmap. So I think in the next stage for OceanBase will be moving forward is trying to reaching out to the next stage for the data, meaning that trying to maybe stay more close and attached to the external different data formats, meaning that it has to be transferred from a database to a lake base. So lake base will be in this year, we'll be spending more time for the team to develop and push to the market, which means that in OceanBase lake base, you can just put your storage in the S3 and sharing storage. You can deploy it on premise, you can use it on cloud. And the most important here is that this OceanBase lake base can attach with the lake base layer of different format and deal with the both the analytics and the pointing select, and maybe you're as in the query, as in the RDBMS. So basically, you can take both part of the advantages in the part, and things that the data compression and the scalability kind of the advantages can help with the model training kind of some kind of the scenarios in this case. So I think that's all for today's my sharing. Thank you.